Hazel Weakly. I am having a lot of fun helping to run infrastructure and developer experience in my current company. I also serve on the board of directors of the Haskell Foundation, and I have a lot of opinions online. You can find me pretty much everywhere, and I am really excited to be here today talking about context, abstraction, and threading the needle. So I'm going to go over kind of like a primer of observability and talk to you a little bit about how I think about it and sort of what that context is and the historical, why do we need distributed tracing and how does that tie into observability? And then we're going to talk about some components of the distributed tracing, mainly context. And then we're going to talk about abstraction and a lot of difficulties that you can run into when you're trying to actually, in real life, build out libraries or build out platform team or build out something other than just manually instrumenting all of your code and writing everything from scratch. So let's get started. With observability, you have your system, you have everything, and you want to figure out what's going on. And over time, people have run into this problem. And different groups of people have come up with different definitions for observability. So one definition that you've heard Charity Majors and a lot of other people from OpenTelemetry and tracing backgrounds and distributed system backgrounds talk about is the one from control theory. And that is the ability to measure the internal state of a system based on its external outputs. And so this is a definition that you see repeated in a lot of places. It's a great definition. I like it a lot. But it isn't necessarily the entire story. One other definition comes from a different theory of practice, which is cognitive systems engineering. And so for them, their definition is feedback that provides insight into a process and the work required to extract meaning from available data. So I like this definition for a lot of reasons, mainly that it does a really good job at showing that observability is really this back and forth dialogue. You need to not just have, oh, you can observe everything. Well, that's cool once everything's built out. But like, how do you get there? What does it mean? And the whole process of people are involved too is something that this definition kind of highlights. And I love any technical definition that includes people. It's my favorite. So speaking of which, my personal definition is, I'm not biased, but I like this one the most. And this one is, I took the other two definitions from cognitive systems and from control theory and kind of blended them together. And so for me, my definition of observability is the process through which one develops the ability to ask meaningful questions and get useful answers. So the way I think about that is it's a process, which means it has to be evolved, and you start from somewhere, but you're not going to stay there. You're going to continually figure out what observability means to you, and it may mean something different today than it does tomorrow, than it will next week, than it did last week. And then additionally, meaningful questions is really the thing that observability to me hinges around. Can you ask a meaningful question of your system, which may or may not involve computers, may or may not involve people, may involve like a whole bunch of different things? And are those questions meaningful to the business, meaningful to you, meaningful to what you need out of that learning? And in asking those questions, can you get a useful answer? So I like this definition for me because it includes every aspect of observability, in my opinion. Like if a CEO wants to say, hey, I have this meaningful question, which is, I want to know where we are in the market compared to where we want to be in the market and how feasible it might be to get there. Can they answer that? And then can the CTO say, like, how is our tech stack doing? Like, how are we poised to build like what we need in order to approach our problems for the next 5 years? How are we setting our engineers up for success? How are we keeping them happy and healthy? That's a meaningful question. An observable system will let you answer that. And for engineers, a lot of that observability questions, it's going to come down to things about the system, things about code, and we're going to dig a lot more into that today than the other questions. But it does remain, they're all part of the same system, and we should all be working together, and we should all be able to collaborate in order to actually solve all these problems and get these answers. So for me, a meaningful question is one that maximizes how much you learn about the system that you're participating in. So like, if you have that system and you want to know more about it, what does that mean? How do you get there? What are you doing? Right? So for programming, we have all my code disappeared. Brilliant. Awesome. I love syntax highlighted problems. All right. So I'm going to figure out what happened there super briefly. And then fix that. And then get back. And if I can't fix it, then I'll just tell you what was on the slide. Oh, oh well. All right, let me share my screen again. And I'll just tell you what was on the slide. Sorry about that. I debugged everything and we're learning in production. Awesome. So imagine on the slide that you have a typical system in which you have someone and they're running a web server and they are asking themselves, what is this web server doing? And so they look at the logs, and the logs in the web server have no data whatsoever. Absolutely nothing. Nothing's there. And they're like, okay, now what? What do I do? Back in the good old days, what you probably would have done was you would have just killed production, taken the whole thing down, launched a debugger, and just stepped through the entire system, step by step, and solving everything. You can ask a lot of meaningful questions that way, and you can get a lot of useful answers. Everything's solved, and all you had to do is completely take production in order to do it. Which is, maybe not the best approach, but it is, it's an approach. That's what we did for a long time, and in many ways, it still works. But one of you have the constraint of, so I want to observe without interruption. I want to, keep everything running and ask meaningful questions of the system. And now I'm considering the system running as part of that question. So let me try, adding some print statements, which again, we're seeing a little bit of lack of observability here in the slides. That's fine. So if we have a print statement and we added them everywhere and we now have a real logging, this is awesome. So you can imagine us taking the web server and getting those logs and looking through, and you can see, oh, hey, this one user logged in, this one user made a transaction, they were able to do something, and then they logged out. That's awesome. We have everything there. We have it done, and we're ready to go, right? Is everything there? Well, so you have the web server and you have the backend. And unless you have very carefully, done everything with your logging, you'll notice that the front end and the back end, nothing's tied together. The front end might say, oh, the user checked out. The user bought something, the user logged out. And the back end might say, this database made a transaction, this database made a transaction, this database made a transaction. And you have nothing to tie those two disparate pieces of information together. So you're like, okay, I still can't really understand anything about the system. I know what each individual piece is doing, but I have nothing to tie it all together. Context, it really ties the system together. So context in OpenTelemetry is for cross-cutting concerns. In the documentation for OpenTelemetry, they say that context is a propagation mechanism which carries execution script values across API boundaries and between logically associated execution units. And that is awesome. Let's break that down just a tiny bit. So context, let's skip all the middle bit, carries values. Context is the glue that turns a bag of data into a unified trace. So what does that mean for you? What does that mean for the system? What does that mean when you're trying to understand it and instrument it? So let's break down and deconstruct context. You're going to have, for each span, you're going to have a whole bunch of context in there. You'll have like the span ID, which identifies that, the trace ID, some trace flags, and a trace state. You're going to have essentially everything that identifies the span, of which there are many spans in one trace and many traces in one system. Span links are another type of context. And they say, hey, this span is related to mine. So you can think of traces as a graph. Spans are nodes, and then links are the edges. So if you have a graph that's a tree and you're like sort of building it down, and all of a sudden you need to take this one span over here and this one span over here and to say, well, they're kind of linked together. You build that link and that's an edge in that graph. Links can be really confusing. They can be kind of weird. They're not always integrated very well in the whole setup, but they are needed for expressing some types of patterns, and they are what turn OpenTelemetry traces from a tree into a graph. And so they're the most expressive thing you have in there, and also the hardest thing to work with at the same time. So currently, you can only add them at span creation time, but people want to be able to add them at any time, and that may happen in the future. And when that does, you'll be able to have a non-directed graph rather than a directed graph, which will be fascinating. Another type of context is baggage. Baggage lets you propagate keep value pairs downstream. It is widely regarded as a questionable thing to use. I know many people who have outright banned it in their code base. It's a bit of a foot gun, but also very, very powerful and flexible. It is one of the ways to send information downstream, but you still can't use it to send information upstream. And I'll get more into what I mean by that later. But baggage is there. You may eventually need it. I kind of hope you don't, but it's there when you have it. So when you have all these different types of context, and you have these different services, and you have these different processes, how do you take this context and actually use it to glue together everything and make it usable? You have the in-process context, and then you have the cross-process, and how to propagate things from one thing to another. And then you have from process, which is getting everything in and actually taking it in the next service and going down that way. So I'm going to go over all of them in order. So there's some code here. Sorry about that. I've never even probably noticed context in process. It's the normal context. It's very typical, very standard. And this is what you see in the documentation. This is the in-process context. You create an active span, and then in that active span, you do some work. You create another active span, and then that context that links the two actually happens pretty much automatically, and you never really need to think about it. The library and the SDK will handle all of that for you. Sometimes, however, you do need to add it explicitly. And this is an invisible code example showing you that you need to do it explicitly when it comes to making links and doing things that way. I'm going to... One second. Oh, amazing. I'm going to pause my screen, stop sharing, and then share something different. It turns out I accidentally made my syntax highlighting only work in Firefox. That's what that was. Oh. Yay, there we go. You can see here that we have the current span, we have the span context, and we get that context and pull it out manually, so then we can create a span with a link. And we need to do that in order to propagate things manually for this type of context information. But typically, you don't really need to do that. And things through, it just magically works. With links, you need to do it normally. So that can be a little tricky. Cross process. There's two steps involved. You serialize the context, and then you yield it over the internet. So serializing the context into a header, it can actually secretly, don't tell anyone I told you this, but there's no reason context needs to be in a header. You can do anything with any transport mechanism that you want to. It's just really serializing the context needs to happen somewhere, and then that needs to be attached to the payload of your call. So I know some people who have actually serialized their context and embedded it into an RPC call as a way of actually instrumenting and tracing embedded systems. Some people have done that with their own bootloaders, which is actually really cool. So it doesn't need to be a header. Go wild. If you want to use the libraries and not write everything yourself, though, all the OpenTelemetry stuff, we'll stick it in the HTTP header for you. So what that looks like is you have from the sending service. The sending service is going to inject with the propagation object the current context into some output object. And so that will do the serialization process. And then you'll have a trace parent and a trace state in that output, and you can use that over the internet. The trace parent is actually the only thing that you need. The trace state has a bunch of other stuff, but you don't actually need it, and you may not want it. So the trace parent is the trace ID and everything required to actually link the span from the net system over. And the trace state has all the other fun goodies that you may want, but may not want. Some people I know have banned using trace state in context propagation because of issues it has that I'll get to later. The context run process. This is the second process. We've yielded everything over the internet, and now we're ready to receive that and actually integrate it. And those are those two steps. So for this, you get the propagator, you ingest everything, and you deserialize that context, and you extract it. And then you take that extract context, and you make it your current context. You don't need to make it the current context, but typically that's what people do. Sometimes people use the trace state in order to determine whether or not they should make the context the current context. And you can maybe want to do that sometimes if you don't always own your systems end to end, and someone may be putting something in the middle somewhere. That can be really tricky. I know that some OpenTelemetry vendors, for example, have run into this problem of you need to really make sure that your context is your context before actually making it your current context. So that's a lot of fun. And then once you have that context, then you've extracted it, you set your span, and just start working from there. So that is moving the context, graphing everything together, and you have all of that, and that is great. But that is all really about manual instrumentation. That assumes that at every single point in every service, you are writing all of your code, you're writing all of your instrumentation, you're writing everything from scratch, and you're writing it right there in line with all the code in an intrusive manner. But if you don't want that intrusive style and you want to be able to build something for other people to use, this is where you start to run into a lot of problems. And we'll get into this now. This is, in my opinion, one of the weakest aspects of tracing in general, and it's a sign of the immaturity of the ecosystem, but I have a lot of hope that it can be improved, and I'm looking forward to seeing what happens there. Do you remember earlier when I said that context is about cross-cutting concerns? When you have a cross-cutting concern and you tie everything together, what you also have is cross-cutting breakage. Because one of my favorite laws out there is Hiram's Law, which says that with a sufficient number of users of an API, it does not matter what you promise in a contract, all observable behaviors of your system will be dependent on by someone. Which means that the more instrumentation that you add into your system, the more things that you're adding that can be observed by yourself, but also the rest of the system. And so, paradoxically, when you cross service boundaries, in theory, you should only depend on the public API service. It's a very standard service-oriented architecture and things like that. But tracing actually doesn't do that. It's out of band, intentionally invisible, not part of the API. And if you fiddle with anything anywhere, it'll propagate to the rest of the system, and you'll end up having a lot of essentially convention and hand-holding and little manual pieces put together that will break every time you change something. So those out-of-band information become in-band semantics. And this problem is something that you see in a lot of different ways. For OpenTelemetry, it's actually specifically about this context propagation, but in form of verification, you see this in terms of the internal implementation details of a function, changing the proof required to show that it's correct, to show that it's verified for a property. And in distributed systems, you can see this in the end-to-end property of networks, and in lots of other places. You can see it. Probably one of the easiest ones is the fragility of snapshot testing for front-end design systems. If you've ever worked on those, you know that you can make the tiniest little change, everything still works, and somehow you just broke your entire test suite because some lines moved here and there in the code itself, or something changed here and there in the code itself, or in like the HTML, but the actual appearance and everything's fine, and you end up dealing with this frustration and this friction of the out-of-band information becoming in-band semantics, and that mismatch causing breakage. And so in OpenTelemetry, baggage is flexible enough to cause a lot of headaches if used wrong. Context is key, and when you have this cross-process propagation, you lose the ability to have your out-of-band and in-band semantics match up and be enforced across boundaries. Additionally, when you're designing abstractions or you're wrapping them, that same out-of-band information will be very painful because you can't necessarily build anything that actually lets you do this in a reusable way unless you build a shared library of semantic conventions. And speaking of which, good abstractions are both transparent and opaque. What I mean by that is they're transparent in that you don't have to know that they're there and you can just reason about them at that level of abstraction. So a good way to think about that is, for example, HTTP requests. They just happen, and they're just there, and you don't really have to know that they're implemented on top of a bunch of wire, glue, terrible crimes, and weird packet header loss information, blah, blah, blah. There's a lot of trauma behind that, but you don't actually have to know that. But that said, you can know that, and the transparency there is that you can reason about everything at that level as if the abstraction wasn't there, and you can write things that are aware of the fact that the abstraction is there and actually work through it in order to know and understand the underlying system. So having that abstraction means that you don't need to know the system underneath it, but that the system underneath it doesn't make it less understandable. OpenTelemetry and out-of-band information in general makes both of those goals hard to achieve because the out-of-band information is not actually semantically embedded in the system when it becomes relevant to the system, and so you can't build an abstraction that lets you operate without knowing the internal implementation details, and you don't actually have a way to observe the internal implementation details and know what they are without just brute force memorizing those conventions. And so that gives you this quandary of what do you do with that? And this can manifest in a couple of interesting ways. But a different problem of abstraction is actually this one, and this is a problem that I run into the most, which is what I call the lifecycle problem. And that is, you have tracing, which is a graph, but you don't actually have a way to really manipulate the graph very well. And that shows up in two ways. The lifecycle problem is the first way, which is that sending information up a graph or back in time, so to speak, isn't super possible or convenient or really ergonomic in any way. And then adding things after the fact is not possible either. So you can't like patch up things as you go and like incrementally build up or out of band build up a view of the graph that's more complete. So here's an example. We have a web server, a service, and a client. And so the web server has, one event, one span, and then a second span. Service has one span, and then the client has one span. And they have overlapping timelines. Here's problems that I ran into trying to deal with building this. So the first span in the web server can pass information to the second span when creating it. And that's totally fine. That works. That's amazing. That's awesome. However, it has no real way to pass information to the second span after creating it. So after you've created that child span, the root doesn't really have any way to continue to add information. It doesn't have any way to modify that, and doesn't have any way to like dig down into the tree and continue to add things. If you have intrusively instrumented everything, you do have the reference to the span, and in theory, you can work with it. Well, if you're building abstractions and you're building libraries, you don't have that. So you don't have a way to send information down. You have packets, but it's almost feels like a workaround. It doesn't feel like it's embedded in this idea of how do I add things into the system and build this graph. Conversely, the child span doesn't have any good way to send information to the parent span conveniently at all. It's possible if you know how to do it. It's possible if you know how to build workarounds with that. You can even build conventions to make it easier, but it's not actually convenient in any way. The web server is able to pass information to the service and then the client via context propagation, which we talked about earlier. And that's possible, that's great, that works. However, the service and the client essentially have no way to pass any information back up to the web server. There's just, that's not happening. Forget about it. Another thing that's interesting here is if you notice, the lifecycle of the web server request is actually shorter than the lifecycle of the whole trace, which means that tail sampling is not going to work as you might expect. Tail sampling really wants you to have a full strict tree with a scoped call stack lifecycle. So the web server or the root span has to be the longest span, and everything else has to be inside of it and organized nicely so that you can make a decision once you've collected everything. And when you have these asynchronous timelines and you don't actually know how long everything's going to be, you don't know how long to wait to make a final decision, and you end up just guessing. And so it becomes heuristic based rather than, oh, let's actually do things, which can really, really bite you if those heuristics are used as part of filtering your traces and actually trying to sample things. So tail sampling distributed traces is actually really, really hard. Another problem is that once a span has ended, you have no way to add information to it. So even though it is technically possible to try and add information to a span from the parent, you can add information to a child span in some ways. That only works if the child span hasn't ended yet, and you have no way to know whether or not adding that information worked. So you can end up with code that adds information to a span, works great, works perfect, you ship into production, it's awesome, and then someone optimizes the child function and makes it take half the time it used to, and then everything starts breaking silently because you didn't actually know. Then now you're trying to add things to a span after it ended. You can have really weird race conditions, essentially. Speaking of, that also happens, yeah. So you can't add information to the service, and also the child and parent have the same problem. So even in context and even in process versus distributed process, you still run into the same issue. Which means that you have a ton of internal implementation details of the instrumentation, the shape of the code, how the code works, the life cycle of your code, the call stack of everything to keep track of. Which, if you are the engineer writing everything, iterating with the whole system and working end to end with it, that may not be a huge deal for you, and that may actually be there. And that's one of the reasons why OpenTelemetry goes so deeply in hand with people owning their systems end to end and having that feedback. But that's actually, in some ways, a bit of a weakness and a bit of a compensation, because you can't build an abstraction unless let other people work on top of that. So you have to own your system end to end intrusively, rather than being able to build these abstractions that let you instrument things more effectively. The second problem there that you run into a lot is what I call the graph rewriting problem. So we dig back into this lifecycle problem. You have a bunch of information based on life cycles and when you make spans, when spans end, and how that interfaces with the call stack of the distributed system in general. The graph rewriting problem is this one. The rule of thumb when doing instrumentation is that you have like this auto instrumentation that can build this scaffolding that you would take all of your manual instrumentation and hang it on that. So in theory, you're not really creating a lot of spans. You're using a lot of spans that auto instrumentation already set up, and you're just adding attributes in the right spots, which sometimes that doesn't work, especially when you're trying to write abstract code. You end up wanting to create a span for the abstract code and do that. But in general, the more you can just add attributes to an existing span created by auto instrumentation, odds are the better off you'll be. But that said, where do libraries go in this, and how do they work, and how do you actually do this? So let's look at this as an example. We have a tree of Express client, and then the Express client has some action, something called make request on the client side. And then the auto instrumentation has that get endpoint, and that's still from the client side. So you have the function call, and then you have the auto instrumentation of the actual fetch response. Awesome. That's great. That's cool. Then we go over into the server, and the server has the server endpoint. Then it has 3 middleware functions. And then it has a post endpoint for the sending for an internal call. Then that has the same chain of you post from one thing, and then you go to the next one, and you keep going and keep going and keep going. And you can run into the same middleware, and you can do all that. So if you're going to run into a couple problems here. The first problem is, how do you collapse spans? You don't actually have a good way to do that. What if I don't actually want all of the middleware to be their own spans, and I want to have just one span for everything in the Express server, and just add information that's relevant to it with attributes as I go down? So maybe I want some span events, maybe I just want the attributes, maybe I want things like that, and I don't actually need a span for like the middleware, or maybe I don't need a span for some other things. I don't have a way to like collapse that tree down. And that can be exacerbated by the fact that if you want to search through your system, typically the root span is where you search, or the same level of a span is where you search when you're trying to like index through your data. And so if you have data at different span levels, you have no way to correlate those two pieces of data and do a query in which you aggregate things across those spans. So that's one reason why a lot of good practice is to have very, very wide events and very wide spans and less of them. So that way you have all the data at the same level, and you can do all the correlation and grouping and aggregation and everything else there that you need to in order to effectively look through your data and find something. But if you have all of your instrumentation and your auto instrumentation building a nested tree of like 10 or 20 spans before you actually get to run any of your code, where do you stick it so that it's at the level that it needs to be? And then on top of that, every library, auto instrumentation, and things like that reinvents their weird set of configuration for you to try and make it so that they can help solve some of these problems. So you'll have, if you look through all of the SDKs or all of the contributing libraries for OpenTelemetry, you'll notice this problem over and over. You're like, oh, how do I use, for example, the Express server auto instrumentation? It'll say, you can just use it. And also, here's like 15 different options. Do you want to silence some endpoints? Do you want to filter some endpoints? Do you want to like silence some middlewares? Do you want to whatever? Here's a whole bunch of functions you can use. Here's some callbacks. And we're going to call this callback before and after this. We're going to call these endpoints. And essentially, it gives you every possible hook point you can think of to enter into a system and stick your own code there as if you had written it yourself. But when you don't have this way to write an abstraction, and you end up having to sit there and write the code yourself in all these intrusive endpoints, and you need to have people having foresight in their libraries to put these insertion points for you, you have this very, very weird problem of really people want to like more or less patch the source code of the libraries and the auto instrumentation, and they want to have written all of it themselves. It's graph effectively. Why can't we deal with that? Like, what's going on? I think I cut out for a brief second there. Did everyone catch the last thing that I said? Awesome. So, in conclusion, there are some problems here. There are a lot of things going on. There's some advice on what to do, and I'm going to go through all of that now. So, observability is the process through which one develops the ability to ask meaningful questions and get useful answers. Meaningful questions for you are going to be about learning about the system. How do you collectively get together and advance your understanding of the system, its behavior, how it interacts with you, and everything, and how do you get that knowledge as quickly as possible? Those are meaningful questions. And can you get useful answers from them? If you can, your system is becoming observable. However, observability is interesting because the more you can observe, the more correlations you're going to infer with your data, and the harder it's going to be to discover contributing factors. So just because you can find a needle doesn't mean you need to build a haystack. And when you have more and more data and you keep shoving more things in there, and you have more and more out-of-band data, and you just add more and more layers of things that can give you observability into the system, you should be really careful to look at everything and go, is this actually advancing our understanding of the system, or is this adding noise? Context. So context plus propagation is traces. It's the glue that turns a bag of data points into a unified trace. When working with context, it interfaces with everything that has to do with OpenTelemetry, and in many ways remains invisible the entire time you use it until you're wondering where things are, or how to use it, or maybe you're confused. But if you know how to use context and know what to think about when using context, it can become your friend. One way to map context and map different aspects of OpenTelemetry together is thinking about the shape of those contexts, of those concepts. So traces are a graph, spans your nodes, and links your edges. Despite traces being a graph, they're often actually mostly thought of and best, most ergonomically designed as a call stack, which is a tree that is like perhaps multi-branched, but that tree is very scoped in that the top node is always the widest and the longest, and everything is fully encapsulated all the way down. And that's the most natural and ergonomic way to do OpenTelemetry and tracing, and everything's going to push you towards that. But traces are a graph, and you can actually access all of that graph power when you need it, and sometimes you'll wish you didn't. Observability and abstraction are natural frenemies. They are the two people in high school that love to hate on each other the entire time they're doing everything. And so even though we love OpenTelemetry and we love observability and we love like all this distributed tracing, the problem of needing a large amount of out-of-band context, but also wanting the ability to add and annotate a very complicated problem of your entire system, its business logic, the flow of information throughout the system. Those are all problems that we don't actually have good answers for in general. We don't have good libraries for that. We don't have good approaches for that. And that extends beyond OpenTelemetry and beyond observability. This is just one of those ways that it becomes a very, very obvious problem. And two ways of having that obvious problem are the lifecycle problem, which we talked about, which is where you have this graph, you have the whole power of a graph, but you don't have a graph that is like convergent. You have a graph that you kind of have to statically know the shape of it as you're building it out, and you can't really patch it up and fix it up later. And speaking of that graph, rewriting it is really difficult, if not impossible, and it's very much convention and ad hoc based. There we are. Does anyone have any questions, thoughts, or anything else?
I just want to say, Hazel, that the way that you describe these concepts in distributed tracing and open telemetry are like, I think, the clearest I've heard. So thank you for that. I definitely really appreciate that. I think it's it's like everything now like just fully makes sense. So
Yeah, I just want to echo that's definitely the vibe. It's like, oh yeah, cool. Now I know what I'm writing about for the next 6 months. It's like the stuff that Hazel has put so clearly. It's very good.
Really happy to hear that.
The question that I had is I'm curious how you feel like post processing fits into that picture, like with the collector. A lot of your time is revolved around like developers, DevOps people who are working with the code, like how they're able to propagate data. But what about that like not so much like tail-based sampling where you're deciding right at the moment, but like maybe a little further down the line, being able to connect data points, once you're holding 5 minutes of trace data?
Yeah. So one thing that's interesting there is that OpenTelemetry feels in many ways like an event-based emitting style of instrumenting your code, but it's actually not that. And the collector and other ways of post-processing data is where you start to feel that sort of impedance mismatch in particular. And so because of that, you can run into certain problems like the a great example of that is that links can't be added after spans are there. And so even as far as I know, like once you create a span, you can't add a link to it, even in post processing. And so if you try to do that, things are going to be really janky. Maybe post processing can fix that, but I don't know.
I didn't know
Everything,
that. That's now I'm gonna go like research that. That's wow, cool. Yeah, I mean, I realize I have not done it. I've been like digging through it and haven't done it. So wow, okay.
Mhm. So there is interesting historical context there in that there used to be a method in the OpenTelemetry specification of you can add a link to a span as long as the span is active. Then they took that method out several years ago, and there's been an open discussion in the GitHub tracker for about 3 or 4 years now of this is actually really useful. We do end up needing this a lot, and can we do that? But currently, as far as I know, the only way to do that is at span creation in the options of the for each span, you can add links in there, and that's the only time. Which means certain types of asynchronous fork join patterns or certain types of like that type of thing, really, really difficult to do. And it also means, you can't post process and add it after the fact. And then another way to think about the OpenTelemetry collector that's interesting is I actually view the collector and how to set up libraries and baggage and other things like that all as different types of convention-based out-of-band information and handling. So when you build up conventions in your company or in your system or in anything like that, you can start to say, oh, yeah, if you set this information here, then it'll be there. Or you can actually just assume that we'll have this information because the collector will add it here. So as an example, Equinix Metal had a blog post in which they talked about they set up their collectors to actually add to every span what data center that span came from, what machine that span came from, and then where everything was, what cluster it was in, and all this extra information. So everyone could always query all that information, but you don't know that. Like it's there because you read the documentation and the internal tooling, and you can build internal tooling that works on top of that. And that's all out of band convention rather than something you can actually express in your telemetry itself. Anything else?
Well, I guess if there are no further questions, thank you so much for coming on twice, and for putting this together. I know presentations are definitely a lot more work to put together compared to just, you know, sitting there answering questions. So definitely appreciate the time that you took to put this together, and to share your knowledge with folks. I think there's you know, so much out there on like the novice OTel stuff, but when it starts to get into the gnarly bits, we're definitely lacking in that information. So we definitely appreciate you sharing that. And call out to anybody if you or you know anybody who is interested in sharing some OTel goodies in OTel in practice. We would absolutely love to have you. And also, if you want to share your OTel story, we would love to have you for O&A. And I think we've got a session coming up later this month, right, Reese?
We do. We have a special discussion actually coming up on the 28th. It's going to be about the evolution of observability practices. And actually, Nika is going to be part of that panel, and we'll do a full announcement.
So thank you, Hazel, for everything. And I guess we'll see y'all on the internet.